All right, so today's lesson, we're continuing with how can I make a prediction, writing equations from a table. But tomorrow we're going to take this a little bit further, and we're going to look at that graph piece as well. So we've been writing patterns in our XY tables. In this lesson, we're going to focus on using variables. We're going to try to write the equation instead of writing the rule out as words, try to write our equations and be looking at tables. While working today, focus on these questions. How can you write the rule without words, and what does it represent? So this is about John's giant redwood. If you're not sure what a redwood is, it's a giant tree. These are actually pictures from my vacation with my daughters. They're right here. That's Miranda and Samantha, but this is from about 8 years ago. So if you look at the size of the tree there, or the size of the car compared to the trees, giant redwoods are giant trees. So John, he loves redwood trees. He has a favorite one, and he wondered if he could use it to predict the height of the tree at other points in time. So he had some data, and here's his data. So we see in year 3, the tree was 17 feet tall. In year 4, the tree was 21 feet tall. In year 5, the tree was 25 feet tall. And so I asked the kids how much was it growing each year? And they said it was growing by 4 each year. And how do you know? Because going from year 3 to year 4, the height went from 17 feet to 21 feet. So that means it's growing 4 feet every year. Now, if we went backwards to figure that out, how tall the tree was 2 years after it was planted. So we have to go backwards. Well, if going forward every year I'm adding 4 years, in order to figure out what it was a year ago, I would subtract 4 years. So 17 minus 4 is going to be 13. So that part of the table now is filled in. So we know at year 2 it was 13, year 3 it was 17, year 4 it was 21 feet, year 5 it was 25 feet. And then I asked how tall was the tree when it was planted. Now, using this pattern, some people put 0 because they assume that, at year 0 it was 0 feet tall, but that's not the case. If I use this pattern and go back 2 more years, well, to go back 1 year, I went back 4. So to go back another year, I would go 4 more. So how tall was it when they planted it? Well, it was 5 feet tall. So filling in the rest of this table, when they planted it was already 5 feet tall, and then 9 feet, then 13 feet, and 17 feet. And then I asked them to make some predictions, had ones all across the board. Part of the reason that we write equations is so that we can make solid predictions. And we wrote the rule for this. One way to do it is to do the guess my rule strategy, where what do I do to 2 to get to 13? It's good to look at the 0, because that means I'm going to add 5, because 0 plus 5 is 5. Well, I try it here. 1 plus 5 isn't 9. So I must be doing something else to the input to get my output. So I start by multiplying. 1 times 2 is 2 plus 5 is not 9. So I go 1 plus times 3. 1 times 3 is 3 plus 5, not 9. 1 times 4. Well, 4 plus 5 is 9. That seems to work. So I'm going to try it here. 2 times 4 is 8. 8 plus 5 is 13. So that seems to be the rule, that I'm going to multiply my x, my input, by 4 and add 5. So one way to do it is to use our input to figure out our output. Another way, and the rule comes out to be, to find my y, I'm going to multiply the x by 4 and add 5. But another way that we could write this equation is, if my growth is 4, that means every year I'm adding 4. Well, repeated addition is the same as multiplication. So I would take that 4 and multiply it by the year and then add 5, because that's my beginning. So another way to write this equation is y is equal to 4x plus 5. One last thing now, to use that in order to figure out how tall it would be in the 50th year, you would plug in 50 for x, because it's growing 4 every year. So 4 times 50 is 200. That's how much it's grown, plus the original height of 5. So it would grow